It is now my great pleasure to welcome our SEA keynote speaker, Dennis Driscoll, to the stage. Dennis has been working in the field of acoustics for over 30 years and has a particular interest in noise control and hearing conservation. Dennis is a past president of the National Hearing Conservation Association in the US, is a fellow member of the AIOH and a past chair of the AIOH Noise Committee. Ladies and gentlemen, Dennis Driscoll.
Thank you, Simon. Well, good morning. Hello. You're such a beautiful crowd. Everyone say cheese. You know, I realized when Simon was introducing me that he doesn't have an accent. I do. But I think we'll be okay and we'll be able to deal with it. First, I want to thank Simon and the AIOH organizing committee for inviting me. Laura Loschiavo for all her assistance with leading up to the conference, and Graham Poe with Safety Equipment Australia Group for sponsoring my travel, and his assistant Lisa Judges for all her valuable assistance with getting my arrangements made. I've been involved with hearing loss prevention and noise control engineering for just over 36 years, and it truly is an honor to be here today and share my experiences as part of this conference. But before we start, I want to give you a little bit of a geography lesson on where I come from so that we're all a little bit familiar. I'm out of the western part of the United States, outside Denver, Colorado, and I've been fortunate over my career to have worked in many different countries, and this will be my 30th country that I've been able to work in or participate in noise and hearing loss prevention type of presentations or other type of consulting work. Now today, I'm going to talk about information on the risk of noise-induced hearing loss and methods to prevent it. I'll also show you how to quantify the costs for managing a hearing conservation program, how to determine the break-even point or the return on investment with regard to mitigation for noise control. Finally, I'll discuss barriers and solutions to overcome these barriers. And in keeping in your with regard to your conference theme, my goal is to provide you hygiene that works through proven concepts that'll enable you to take home and apply a lot of this information on the workplace. You know, I've read studies where it shows that over 1 million Australian workers are exposed to hazardous noise, and noise-induced hearing loss is your number 3 occupational disease. This compares to more than 30 million US workers, where hearing loss is the number 2 occupational disease. So clearly, noise-induced hearing loss is one of the more prevalent occupational diseases. And really, regardless of the country, the economic burden of hearing loss impacts not only the workers and their families, but also business owners and the wider society. The challenge in dealing with noise-induced hearing loss and the exposure that results is that it's very gradual. Unless there's a traumatic event, like an explosion, a gunshot, or you stayed too long at the welcome function last night, occupational noise-induced hearing loss rarely results from a single exposure, but instead the effects are gradual, insidious over time. And it takes years of unprotected exposure to really start to develop noise-induced hearing loss. The image we're seeing here is actually a cochlea from a cadaver that, at the time of death, had extremely healthy hearing. This is a dissection of the cochlea, and the perpendicular dark lines is the stereocilia, or the hair cells. If we zoom in a little bit on them, we can see the inner hair cells on the top row and the outer hair cells in the bottom rows, the 3 rows there. And they're well organized, they're healthy, they're not damaged. But unprotected exposure over series of years with high noise, you can start to wear out and kill off the hair cells that are sensing the signal that's introduced to the inner ear. Now, noise is just one of many different reasons you're going to lose hearing. You can have viruses, disease, head traumas. You get ototoxic effects from chemicals in the workplace like toluene, N-hexane, styrene. Then you get ototoxic effects from some medications. And then there's the obvious event of aging, also known as presbycusis. But if you go without hearing protection and you're exposed to excessive noise over a long period of time, years, even decades, you'll absolutely destroy all the inner hair cells that are there to receive the signal, and you'll have total deafness, as indicated in this image where you can see that the hair cells no longer exist. They've been blown away and worn out over the decades of exposure. Now, because damage to noise takes years to fully manifest itself, what happens is affected people really don't recognize they're losing their hearing until significant damage has occurred. The key point is that noise-induced hearing loss is permanent and it's irreversible. We cannot regenerate these hair cells. This is a key point for employees to always understand. A lot of employees will have a misconception that they can simply get a hearing aid at the end of their career, which will help them restore their hearing. You know, nothing could be further from the truth. You know, eyeglasses are very good at correcting your vision back to 20/20. That's a muscular issue. But when you get into noise-induced hearing loss, as I mentioned, the hair cells have been destroyed. They're no longer there. You can't regenerate them. So all a hearing aid is going to do is amplify the sounds that it's present introduced to you. And if you have the hair cells in those regions, you can actually help improve the hearing. But with regard to noise-induced hearing loss, it rarely will enable the person to hear anything regarding normal hearing that they had before. Now, fortunately, occupational noise-induced hearing loss is 100% preventable. There's no reason we should hurt an employee. And we can prevent this through implementation of our hearing loss prevention efforts. The worldwide consensus on what a hearing loss prevention program is involves the elements that we see here. Now, this concept of noise-induced hearing loss and preventing it has been around for more than 100 years. The programs have continued to evolve, and over the past 30 years, it's moved from a more reactive mode or posture of conservation into a proactive mode of prevention today. Now, it's my firm conviction as a professional that companies need to treat hearing loss prevention more than a priority. It needs to be a value. And there's an important distinction here because priorities may change, but values do not. So this is something that companies need to adopt. Now, from my experience, one of the barriers to noise control is that many companies or employers don't recognize how much they're really spending on their hearing loss prevention efforts. So I'm going to help you quantify this cost, and to do that, I need to segregate out the noise control component of this program from all the other elements. And we're going to put a cost element on the remaining components, and we'll also put a cost element on the noise control aspect, which will allow us to determine where we will have a return on investment should we invest in noise control to mitigate out all the noise problems and eliminate the risk completely. And that's where companies really start to save money. So I'm going to go through a checklist that I've developed. It's an 18-item audit or self-evaluation that you can use to help put the cost on your program at your customers or facilities that you may work at. Now, toward this purpose, you're going to have both direct cost and indirect costs. Direct costs are obvious things like how much do you spend per year on buying hearing protection devices, on hearing tests, on instrumentation, and then some of the more difficult items to quantify is the indirect costs, like what is the time that people spend on the program with regard to receiving hearing tests or being trained or even managing this program. So let's look at these items, and I'll step you through this, and hopefully we'll be able to see where we can help take this information and put a cost on our programs. Now, the first line item is simply how many employees are in the program. We're going to use this number at the end to calculate an annual cost per employee in the program. Now, I'm going to talk about the cost that's been generated through my research, and it's in US dollars, so we can just make the adjustment mentally by adding another 30%. But once I have all these 18 line items accumulated, we'll convert it to Australian dollars so that you can see the comparison. Now, companies I've studied with regard to spending money on hearing protection devices and talking with hearing protector manufacturers, they estimate that the annual cost in investment in hearing protection is about $50 a year per person in the hearing conservation program. Next is the annual cost for instrumentation. What we do here is we take the fixed costs for instrumentation like sound level meters, noise dosimeters, calibrators. And what I recommend is typically they will have about a 5-year lifespan. So you can annualize that cost over 5 years with depreciation. Next, what do you pay for noise surveys on an annual basis? Now, this is where it becomes a little challenging. If you have outside services that do the survey for you, obviously that's a direct cost that you can look up or find out from the purchase order or what you paid. If you are doing in-house noise surveys where your own personnel does this, it's a little more difficult to quantify, but what you can do is you can take the metric that business owners use to justify the position of the worker or the cost for the worker, and it's called direct personal expense. It's taking their average hourly rate times 1.4 to account for all their overhead and benefits. So that's a good metric to basically say, if I spend 100 hours a year on my hearing conservation effort, I can take my salary per hour times 1.4 times the number of hours I spent, and that'll be the estimated cost. Now, I mentioned there's 18 line items here. There's some things you're not going to be able to put a cost to, so just leave them blank. The idea here is to just get a real good cost estimate on what this whole program is going to be costing you here. So next is the audiometric testing. In the US, they spend anywhere from $15 to $25 per employee per year for hearing tests. This is something that I understand in Australia, you typically will test employees every 2 years. So I would recommend prorating this on an annual basis to get a cost estimate. Now, audiometric follow-up and retest, the mobile test services and companies that do in-house testing typically have reported they'll lose about 10% of their workforce doesn't get tested that year. So they have to come in and do the retest either through a clinic or in-house with the nurse. And you can put a cost on what that association for that element is. Next is how much do you spend for your training materials? Do you buy DVDs? Do you have pamphlets? Do you have guest speakers? What does this line item cost? Next is the annual prorated cost for calibration of your acoustical instruments. Same thing with your audiometers if you're doing in-house testing. If you're using a contract services for your audiometric testing, obviously that will be a fixed cost that you can find out from what you're paying. The 10th, 11th, and 12th items here are indirect cost. And again, this is where I recommend using this direct personal expense for the amount of time that a person would spend being trained, being fitted for hearing protection, and administering the hearing loss prevention program. So again, their hourly rate times 1.4 is a good estimate, times the number of hours that they spend per year doing this. The maintenance of acoustical instrumentation is a fixed cost that you can obtain from your facilities, as well as any lost production. That would only apply if you have to take workers out of the workplace to have their hearing tested or fitted for hearing protection or trained. In that case, again, you would apply that direct personal expense. If you had any production that was lost as well, you would calculate that cost. That's a more difficult one to quantify, and a lot of companies I've dealt with have just left that line item blank. The space allocation really applies toward in-house programs. where you have an audiometric test booth or a room that's dedicated to fitting hearing protection as well as testing the employee. You can estimate the square meters of that space and what the rent would be for that type of space. We're really trying to fine tune how much we're spending on our hearing loss prevention efforts here. The expense to certify any hearing test technicians and survey technicians is also an important line item, plus the medical retention. Do you have electronic or physical storage of all your medical records, security costs, as well as backup of your data? And if your company has worker compensation premiums they're paying, the insurers have told me a good estimate for hearing loss coverage is about 1/10 of the total payroll, or 1/10 of 1% of the total payroll. So based on these 18 line items, I've done this research with over 100 facilities. 95 are in North America, 3 were in South America, 5 were in Europe, and 5 were in Asia. The data was collected from 2009 to 2014, and the approximate annual cost for having an employee in the hearing loss prevention program, minus any noise control effort, is about $400 US, which is about $520 Australian. So if you have 100 employees in your hearing loss prevention program, you're spending at least $5,000 or $50,000, $5,200. So you can do the math there. Actually, it's over 50,000 Australian dollars. So this is something that is a good metric to help compel management to understand what they're investing in their hearing loss prevention program, because a lot of times it can help offset and justify the cost for noise control. Now, toward the noise control determination, this is another difficult metric that you can calculate or get calculated with assistance. The first is you need a comprehensive, detailed noise control survey. On this aspect, I really recommend you use a professional for this. Somebody that can clearly identify the sources of noise, quantify the interrelationship between individual noise source and receiver, develop all the noise control options and recommendations, and solicit cost estimates from the suppliers or manufacturers of the noise control systems. There, they can put a quantified cost on what that type of effort is going to entail over time. You're going to have some project time for managing this whole effort, and that's the same principle I described a moment ago for participants in the hearing loss prevention program, where you would use the administrative person here, their hourly rate times 1.4, and the number of hours that they spend. Now, noise controls systems are not permanent. They do wear out over time. They need maintenance, and they need updates. So a good cost estimate for that is about 10% of the capital cost of the initial purchase is what you're going to spend on maintaining that device over time. And I always like to advise employers to add some discretionary funds in case they should have some unforeseen incidences and have some runovers. The cost on this I've estimated for one manufacturing company that I've done a lot of research with and noise control work with over several years. The company is a manufacturer of consumer products. For confidentiality reasons, I need to keep their identity private, but historically their noise exposures range from 82 to 88 dBA. This is over a 5-year period from 2008 through 2012. And the project goal was to implement engineering controls to mitigate all their sources and get their noise exposures below 80 dBA. So this was performed at 12 plants. It had an average of 200 employees per plant. The average cost per facility to retrofit and maintain these noise levels over time for this company was approximately $375,000 US. Now, some companies may be twice that amount, some may be less. It will really depend on the industry. Again, this was a manufacturer of consumer products, so a lot of their noise issues tend to be in the realm of compressed air issues and machine guardings that could be upgraded for acoustical benefits. So that cost may be a little low for some industries, but it gives us a magnitude to work with here. So now that we have the cost for the participants in the program, and we have a estimate for the engineering part to mitigate out that noise, we can look at what would be the return on investment to implement those engineering controls, and when we would start to have a crossover point where we would save money over time. So the return on investment is calculated by the cost for the noise control mitigation divided by the annual cost for all the participants in the program. This company had 200 employees, and I'm using the figure of $400 per year per employee, and the return on investment was estimated and calculated out to 4.7 years. I've done this with a few other industries with just a couple facilities, not the 12 plants like this one company. And it really ranges between 4 and 7 years where you can fully engineer out all your noise controls. Then the challenge is sustaining that over time, which requires a concerted effort. But again, that's a reasonable number that management can get their minds around and their arms around to understand where they're going to start saving money. After this 5-year period, this manufacturer is no longer spending the $40,000 a year on their hearing loss prevention program. They're spending probably about 10% of that, just providing hearing protection for comfort. So what are some of the barriers to success here? Well, this is what I've defined, and there may be other barriers, but the first is time. You know, health and safety professionals, they have a lot of responsibilities, and with noise being only one of them, they're managing too many, really in my mind, they're handling too many issues, but they need to keep noise and hearing loss prevention as a high priority because, again, you have your number 3 occupational disease is noise-induced hearing loss. So it is a high priority. Next is resistance or indifference. Now this could be something that management has and or the employees. It's often common for employees to resist wearing hearing protection devices or wear them effectively when they're in the workplace. Sometimes noise controls are a multi-phase approach. It takes years to really engineer out enough noise to really have a noticeable difference. So management can lose patience with regard to this whole effort. So it just needs to be a dedication to where you stay persistent with it. Another issue is perception. Management doesn't recognize sometimes that if you reduce a noise source by 3 decibels, that's half the sound energy, that's half the risk. But to the human listener, because the logarithmic nature of decibels, it's barely discernible to the listener that a 3 decibel change sounds dramatic. So that is something you have to do fairly strong education on the worker and the management with regard to this. It is a significant benefit. Thirdly is money. It's similar to time. You need to justify money to be budgeted for noise control because, again, it is a priority risk for us. And lastly, I've identified motivation as a barrier. I've noticed every successful noise control program and every successful hearing loss prevention program has one common denominator, and that is it has a champion, a key individual that will be responsible for getting management educated, get employees motivated, and carrying the flag for this cause of hearing loss prevention. So let's look some of the options we have to overcome some of these barriers. It really helps to start to have some success in any element that will give some motivation and emphasis to the program. Let's look at some game changers that have occurred over the last few decades. Now, we've already discussed 2 of them. The cost on the hearing loss prevention program per employee is really an excellent metric for management to understand what they're spending every year on their hearing loss prevention effort. The second is this return on investment calculation, because that gives management an objective goal to move toward with regard to eliminating this risk. Some other game changers I've identified are noise control home runs, and I have 3 significant ones I'm going to go through momentarily. Hearing protector fit testing, and early education or encoding that starts early. So let's look at what we can do first to jumpstart our noise control program. The 3 significant home runs that I recommend that anybody here can take home and apply. Again, we're looking for hygiene that works. This is practical information. It doesn't cost much, if anything, and sometimes has a payback. The first is to get a handle on your compressed air systems. Secondly, how you set up your equipment and maintain that equipment over time can have a significant reduction in the noise exposure. And finally, upgrading your machine guarding systems. A lot of companies will have polycarbonate guards that are not for acoustical benefits, but if you add a few dollars to the system, you can significantly increase the benefit from a noise reduction standpoint. Now, let's look at the first one, getting a handle on your compressed air systems. From my experience in 36 years in noise control, across manufacturing companies, compressed air is the #1 noise issue. If it's a plant-wide challenge here. Every machine in the facility, a lot of times, is motivated or driven by compressed air. It's probably one of the more hazardous risks from a hearing loss standpoint. And from a noise control challenge, it's one of the easiest to control. Plus, there's an energy savings and a cost savings if you get a handle on your compressed air usage. Now, compressed air systems are used to motivate equipment, index machines, move machine parts. It's all driven by air cylinders, solenoid valves or air valves. And then you have air systems that are used to assist with the production, like closing flaps on boxes, ejecting parts, blowing up or cleaning up debris around the machines. All of this is using compressed air to assist with the manufacturing. Now, the important thing to understand about compressed air is that the noise level blowing into atmosphere from that high velocity air is going to be proportional to the airflow raised to the 8th power. In other words, the sound level is proportional to the velocity of air raised to the 8th power. So the first step that anybody should be doing in their effort to control compressed air noise is to find that sweet spot or optimum pressure setting that will allow you to operate your machine at the minimally effective air pressure setting, which will reduce the noise level accordingly. The second step is to eliminate all your open blows, as I call them. They're open discharge ports or compressed air lines that are assisting with the production. All of this is, again, causing a high velocity air that's ripping apart the atmospheric air, causing a high sound level. The example I want to show you is from a company that uses vibratory feed bowls as part of their process. They're manufacturing a cream material, so as part of this process, they have to assemble the tube. This is a vibratory feed bowl that was provided by the original equipment manufacturer, and it had 5 crimped air nozzles on the vibratory feed bowl that were used to propel caps down the conveyor track as part of their production. The crimped air line is one of the situations you want to completely eliminate in your plant, because that is absolutely one of the more extreme noise levels that you can generate. So the retrofit is to use a commercially available quiet design nozzle that's designed for this purpose, that will give you the blowing force that you need, but use less energy and provide significant noise reduction. The energy cost is, for example, on that vibratory feed bowl, one of those air nozzles was about a 10 millimeter open pipe. The air pressure that was set was at 5 bar, and that had a flow rate consumption of 185 Newton cubic meters of energy per hour. At an average cost, and again, I've done this in US dollars, is just a little over 1.5 pennies, or 0.015 US dollars, per Newton cubic meter of blowing force. They estimated this vibratory feed bowl was used about 40% of the day. So on an annual basis, that's about 704 hours of usage time. So the annual cost for operating just one of those airlines on that vibratory feed bowl was $1,954. Again, we had 5 of these airlines. Now the retrofit is to install a commercially quiet design nozzle. For example, one manufacturer is called Sylvant Incorporated out of Sweden, and they recommend using a model number 705 quiet design nozzle. That has the same airflow service so that you can get your production completed, but it only uses 95 Newton cubic meters per hour of flow rate. So a Sylvant quiet design nozzle looks like this. If you look closely at the top of the nozzle, you'll see different lengths of slot openings, different widths. All of this is a science that is designed to step up the air pressure in milliseconds, which doesn't cause the severe turbulence you get with the crimped airline. So there's a real science behind these designs. Now, the annual cost to operate one of these airlines with the quiet design nozzle is just over $1,000. So the difference in savings between the open pipe and the quiet design nozzle is $950. And again, we have 5 of these nozzles on the bowl. So this company is spending almost $5,000 a year just in lost energy and excessive air pressure to operate that bowl. Now the quiet design nozzles will give you on the order of 20 decibel reduction. The cost for these quiet design nozzles, it has a return on investment easily less than 12 months. So it's definitely something that is worth the investment. In my mind, this is simply a no-brainer. There's no reason a company should have excessive noise. Do the compressed air. There's so many feasible and practical solutions available to get a handle on these compressed air issues. Now, the second issue I want to talk about, or as far as home run and noise control, is your equipment setup and maintenance of the equipment for noise control. This is a machine that makes, starts to form the box that you put your end product in. And part of the process here is, I'm going to play this short video here, and I want you to listen to the impact you're hearing on both ends of the stroke. There's a push bar that's pushing horizontally that's going to put the flap up on the box, and then you have the arm, or ram as it's called, as it's retracted, will have a heavy impact on the back end of its stroke. So when I looked at this machine initially, the air pressure driving that push bar was set at 8 bar, and that's pretty high. That's the line pressure they had in the facility. We worked with the facility maintenance people and reduced the air pressure down to 5 bar, and we're able to see if the machine still functioned properly, and it did. So I took noise measurements before and after, and let me explain this chart. This is a presentation of the third octave data, and on the vertical axis, we're looking at the A-weighted sound level per third octave band frequency across the horizontal axis. The red line is a depiction of the initial condition at 8 bar, and the noise level standing 1 meter from this machine was 94 dBA. When the air pressure was reduced to 5 bar, we took a second reading, which is depicted in blue, and we see that it dropped down overall magnitude to 84 dBA. So a 10 decibel reduction. You know, I mentioned earlier that a 3 decibel reduction is barely perceivable to the human ear because the ear is not linear. A 10 decibel reduction, as a layperson listening to that, you would tell me it's half as loud because, again, that's the way the ear reacts to that magnitude of change. So this was a dramatic effect, very noticeable. It's a significantly lower risk to the workers, and it's less wear and tear on the machine. So again, how your machines are set up and how they're maintained over time is another critical home run that you can have toward trying to get down these noise levels and have some success here. Now, equipment setup and maintenance has a lot of advantages. It provides for efficient operations of the machine. Components, it saves energy, and it saves cost. It minimizes the noise levels. And as I mentioned, it minimizes the wear and tear on the machine. That also helps improve the function of the machine so that the worker is not spending time up close to the machine fixing any jams or any type of issues that you might be having with the machine. So it all has positive benefits associated with it. Now, the third item I want to talk about is upgrading the machine guarding that you already have in place. Typically, you want to eliminate all your air gaps so that you don't have that noise propagating out into the space where the workers are. Companies often use enclosures for multiple purposes. They could be for acoustical benefits, or it's part of the machine casing, or you build in polycarbonate or Lexan plexiglass type of guarding systems to protect the worker from getting injured by the machine. But if you look at these guard systems and you look for any of the air gaps and small flanking paths that allow sound to propagate out to the open space, you can identify where we can try and mitigate that. For example, in this machine, we can see along the bottom edge of the machine, there's a large gap between the bottom of the machine and the floor. When we look at the adjacent panels where they come together, there's about a centimeter gap between the adjacent panels. Now, the rule of thumb that you can take home and help get management to understand is on the order of a 1/10 or on the order of a 1% opening, you're going to lose 10 decibels of attenuation that's available for that machine. For example, this is a image that was taken around one machine that had a very nice dense rubber skirting around the base to seal it against the floor. But on one side of the machine, they interrupted that seal with the conduit, electrical conduit. And the noise level on the left image is 95 dBA. On the right image, it's 89 dBA, which supports my rule of thumb here that a 1% opening is going to allow at least 10 decibels to escape. So these are 3 home runs that I think you can have a lot of success with. I promise you, if you pay attention to your compressed air systems and get a handle on those, maintain your machines in good working order, and make sure they're set up properly, and upgrade all your guarding enclosures to eliminate all those air gaps. It doesn't have to be an acoustical product, it just needs to be any type of product that'll seal it and keep that noise from dissipating and propagating out to the workspace. You will have the greatest noise reduction benefit for the least amount of money invested as possible. And it helps get the ball rolling with regard to motivating management toward doing more things that may be more challenging with regard to noise control. Now, the fourth home run, or game changer I want to mention, is hearing protector fit testing. For more than 40 years, we've been dealing with a single number rating called the noise reduction rating on our hearing protection devices. That's been helpful, but it's not ideal. There's an issue with the noise reduction rating that it's a laboratory number, so often trying to determine what the real world performance is in the workplace, you make derating schemes where you adjust that noise reduction rating from the manufacturer by 50% or some other factor. The game changer in the last 10, 15 years that I've seen is going to hearing protector fit testing. Just like respirator fit testing, this is where you test them with their hearing protectors. And that allows you not to use the noise reduction rating, but a personal attenuation rating, or PAR value. The methods available involve 2 different types. 3M makes a product called EarFit that involves a field microphone in the real ear. What this involves is their hearing protection. They provide it with microphones that are provided on the outside of the device as well as under the device in the internal ear canal, so that you can measure the actual objective attenuation that worker gets in the noise field that they're tested in. Now, Honeywell makes a system called VeriPro, which is more of a subjective type of assessment. It's still very good. That's called the real ear attenuation at threshold, where they sit in a booth or room and they're introduced to noise and they perform a balance measure subjectively, balancing out the two left and right ears. If either of these systems are available here at the exhibits, and I don't know, I highly recommend you test them and learn about them yourselves. But these are real game changers. My friends at Honeywell gave me a slide that I want to reference here that is from employees that have given their testimonials about these fit testing systems. The comments that they've stated are, I know how to better fit my earplugs now. I learned a lot about the best earplug for me. I was amazed the results after being shown the proper way to use my earplugs. I feel I'm better protected. I found a more comfortable fit, and it was very beneficial. I had no idea I was not using my hearing protectors correctly. And the most important one that I thought was stated by the worker is, I'm very motivated to wear my hearing protectors now because I know how well they can work. So again, this is a real game changer. I highly recommend that companies go to the hearing protector fit model and implement that at their programs. The key issue is it's an excellent tool to train the trainer that fits the hearing protectors, to train the workers so they recognize when they have a very good seal on their earplug, and it provides the appropriate assignment of hearing protectors so that you're not overprotecting a worker or underprotecting the worker based on the noise levels. It eliminates the noise reduction rating derating schemes, and it assists in helping determine work relatedness. If the employee is proven to be wearing their hair protection, it has a PAR rating that is documented. So it's got a lot of positives here, and again, it's something that I highly advocate for adding to your program as far as improving that. Now, the last item I want to talk about is encoding. And when I say encoding, I'm talking about early learning. What we learn in our early development is something that becomes ingrained in our fabric, ingrained in our well-being. I got a question. How many of you finished the first grade? Somebody raised their hand. I'm sorry. I thought I was back in the United States. You know, researchers have learned that about 90% of a child's critical brain development happens by age 5. This is where the building blocks or skills for things like motivation, self-control, focus, self-esteem, and self-responsibility are rooted in their early childhood development. I have a personal experience that I want to share with you that brings home this point. This is my oldest daughter, Lauren. I have two daughters, Lauren and Jenny. Today, Lauren is 26 years old and Jenny is 24. But Lauren, when she was starting school, she was really excited about attending public school. And I asked her what was she most excited about. And she said it was riding the school bus, because that's what the big kids do. So Lauren and her mom and I showed her where to pick up the school bus, where it's going to drop her off, and basically ran through the drill with her before she started school. Now, on the first day of school, we had to drive her there in the morning to complete registration, and she was to take the bus home in the afternoon. I'm in my office, and about 3:15, I get a call from the principal. And the principal says, Mr. Driscoll, you need to come and pick Lauren up. She got on the school bus pulled away, and she started screaming hysterically to let her off. And, you know, I'm like, what the heck happened here? You know, she was so excited about riding the school bus. So I get in the car and I drive over to the school, park in the lot, and walk in the lobby. And across the lobby is the principal's office, and it's got a glass window and door. And Lauren sees me coming in, and she comes running out. And she's got she's just crying, and she goes, "Dad, I really, really apologize. I couldn't ride the school bus." And I said, "Lauren, what happened? You were so excited." And she goes, "It had no seat belts." Well, I got to be honest, I viewed this as a positive, not a negative, following Dr. Johnson's description there. I got down on my knee and gave her a big hug and said, "Lauren, good for you." So she had been educated and trained to always wear a seatbelt. You know, my house, our mailbox is 50 meters from the house with a bunch of other mailboxes. And a lot of times, my wife and I would come home and we would stop the car. One of us would get out and get the mail, get back in the car, and we would drive up the driveway. But we wouldn't put the seatbelt on, and she would start screaming at us to get that seatbelt on. So again, early encoding is critical here because, as I mentioned, self-responsibility is rooted in our early childhood development. Now, there's no need to reinvent the wheel here with regard to our young adults or children. There's many organizations and efforts that are underway around the world that I think are excellent to borrow from and use toward this end. For example, in Western Australia, we have the Grow Smart Foundation. Then we have the National Hearing Conservation Children and Noise Task Force. There's Oregon Health and Science University's Dangerous Decibels. Let me tell you a little bit about these. The Grow Smart Foundation, which has a Here Today program, is really an excellent resource that I was looking at in preparation for this discussion. And if you click on their resources page, it'll give you a nice description of a program they have that has educational information for teachers, for parents, and for the student themselves. So again, look for that resource and see what they might have to offer. I mentioned the National Hearing Conservation Association. That's the big hearing loss prevention group in the US that I'm past president of and been an active member for 36 years. This group has a similar program called Crank It Down, and this gives you information again for parents and teachers to deal with different types of situations like personal listening devices, noisy toys, things that parents can do to help educate the child and give them the early warning signs that noise may be a concern for them. Now, the Dangerous Decibel program is very prolific throughout the world. It's actually a strong program that's been implemented in the last 10 years that has certified instructors around the world. I know they've presented many times in Australia and they have other courses in the future. And they actually have 8 certified instructors in Australia with 2 in Sydney, 1 in Melbourne, and 5 in Perth. So you can go to the Dangerous Decibels website and find out who these instructors are and work with them and see if they can put on a clinic for your children or your school. They work very heavily through exhibits and education and interactive games and research. So again, they're a very worldwide known program. Now, there's additional resources in Australia. I just want to reference them. Here for Tomorrow and the Cheers for Ears program. I'm very pleased to see that there were so many different efforts here in Australia relative to other countries that I visited. They've had to rely on what you guys have as well as what comes out of the United States. So those are the proven game changers from my experience in hearing loss prevention. Now, it may only take success in 1 or 2 or just 3 of these elements to really get the momentum to move forward, to get the support from your company. And I really hope that'll give you something you can take home and start to work with, and hopefully it'll help you. Now, before I conclude, I have one more item I want to discuss, and that's to try and make education and training of the person personal. Personal to you, to your workers, to your management. And in order to really touch their heart You have to aim between their ears. So let me show you what inspires me, and that will tell you what I'm talking about. You met my daughter, Lauren, who, this is when she was just a baby, and now I want you to meet my wife, Barbara. Barbara's with me here today, and many of you met her last night. Now, we've been married 28 years, and as she told someone last night, we've been married happily for 27 years. But long before we met, in her teen years, Barbara was in a terrible car accident. And she had a head injury which resulted in significant hearing loss or partial hearing loss in both ears. The issue is something that I've learned to adapt to and adjust to. But when Lauren was 1 year old, she was beginning to speak. You know, if you look at the picture on the right, look at Lauren's eyes. They're actually focused on my wife's lips. So as my wife is forming a word, Lauren is visually seeing how that word is pronounced. So this is when she was first starting to talk. And after a few efforts here, it was my turn. And I was sitting in a chair about 1 meter away from my wife. And I took Lauren in my lap, and we spent 5 minutes doing some words. And after 5 minutes, she had doubled her vocabulary from 4 words to 8. So we were laughing, and we were hugging each other. And I turned to my wife, and I looked at her, and tears were just coming down her cheeks. And she said, "I see you talking, but I can't hear a word you're saying." You know, speaking early is just a milestone in a parent's life, and she had missed out on this. You know, it was at that moment when I recognized the true devastating effects of hearing loss on not just the person, but the whole family, again, in the whole wider society. So as I embraced my wife, I really dedicated myself to embrace this cause of hearing loss prevention. Will you embrace it with me? Thank you very much. I appreciate it. Thank you.
Wow, great. Thanks, Dennis.